Hello students, welcome to my lecture. In this video I will discuss a question from the topic gravitation. This question appeared in previous IIT-JEE mains. The question as follows. Assume that Earth is a solid sphere of uniform mass density and a tunnel is dug along its diameter throughout the Earth. It is found that when a particle is released in this tunnel, it executes simple harmonic motion. The mass of the particle is given 100 grams and they are asking the time period of motion of the particle will be. So, there are a few things we need to clear here. They are telling it is SHM. So, and we need to calculate the time period. So, the idea is you need to be very clear what is the condition for an SHM. The condition for an SHM will be, you all know that acceleration is directly proportional to displacement from the main position and opposite in direction. So that proportional to constant generally we write as omega square. So here omega square will be the related with the time period, that is omega will be is equal to 2 pi by t. So this is the idea. So I need to calculate the acceleration of the particle. So I need to calculate the acceleration of the particle. First of all, the thing is I need to identify the mean position of SHM. Mean position for oscillatory motion. So mean position means the force acting on the particle will be 0. Then later on displace x, displace by x and find restoring force. Find restoring force. So after finding restoring force, we need to prove that acceleration is directly proportional to displacement. Okay, fine. So now I am taking an earth. The idea of course you understood this. So I am taking earth and make a tunnel along its diameter. So let us, this is earth. Now let us draw a tunnel along its diameter. So I am taking a tunnel along its diameter. So obviously when I am at the earth center, the field is 0. Once the field is 0, force is mass multiplied by that is also 0. That means earth center will be the mean or equilibrium position. Mean or stable equilibrium position. So at the earth center, net force will be 0, acceleration will be 0, it will be the mean position. When the particle will be on the surface, it will be attracted toward this. When the particle is here, it will be attracted toward this. So just we are releasing from here, velocity will be 0. So velocity will be 0 here. These are the extreme position. This is one extreme position and this is another extreme position for the SHM. So now let us assume at a given instant the particle will be somewhere here, which is at a distance of x from the center. Then what is the force acting on the particle there? The force will be acting toward the center. Now obviously it is opposite to the displacement. The force is given by mass multiplied by that electric field. That gravitational field here. Then what is the E value inside? What is the gravitational field inside? The gravitational field inside is given by minus gm divided by r cube into x. So this is the expression for E inside the earth. So this you can calculate with the help of even from the Gauss law. So the Gauss law says integration of E dot ds will be is equal to minus 4 pi g into mass enclosed. Or otherwise you can remember it is the standard formula. E value just inside. So once I know this formula, then I can calculate the force will be, the force is given by minus g capital M small m divided by r cube into x. So once I know this, I can calculate acceleration. Acceleration is simply force per unit mass. So that acceleration comes out to be minus g constant, capital M constant, r cube is also constant into x. So it is very clear that acceleration is equal to minus omega square into x. So clearly omega square will be is equal to g capital M divided by r cube. So omega will be square root of gm divided by r cube. Once I know the omega value, so time period is simple. Time period is equal to 2 pi by omega. So 2 pi r cube divided by gm. R cube divided by gm. So now even you can write in terms of g also. So because in terms of g means it is g will be is equal to on the surface of earth gm divided by r square. So if I substitute there, then the time period comes out to be 2 pi times square root of r divided by g. This is the time period of oscillations of that SH. So now it is the standard values. You substitute the r value given as 6400. And you substitute all these values. Time period comes out to be 2 into pi value 3.14 into r value 6400. So kilometers, convert into meters, divided by g value 10 seconds. Answer comes out to be second. So 10 10 ja cancel. So it will comes out to be 800. 64 root is 8. It is 800 seconds. 800 seconds. Now the answer they are asking hours and minutes they are asking. So let us convert into first of all seconds. How many seconds will comes out to be here? So it comes out to be 1 hour. So 3.14 sorry here. Let me calculate with the calculator. So I am doing with the calculator. So 2 into 3.14. Remember in the exam there is no option, you need to do yourself. Into 800. So this is coming out to be 5024 seconds. 5024 second. Then they want in divided by 60. These many minutes. 83 point something 77 minutes. So they want in hours. So 60 minutes is 1 hour. So if you see the answer, so 60 minutes and so 1 hour 24 minutes. So that is very clear. So here it is 83 means 60 plus 60 minute plus 23.77 minute. So 60 minutes means 1 hour. Approximately it is 24 minutes. Okay. As it is a standard question, many students will remember this. So most of the time you people will remember this 84 minutes as it is a standard question. So you need to do this entire derivation. Okay. So try to remember this type of problems. Finally you need to answer. That's it. So they are not expecting you to do all these things and put the answer. As it is a standard question, you need to remember the answer and directly put the answer. Okay. Done. Thank you. Please subscribe my channel and don't forget to like and share. Thank you very much.